Minimass is a way of making low-cost, low-carbon concrete structural elements. We're using 3D printing to allow us to make very specific geometries, to make the shapes which give us the chance to take material away. We're building beams for a footbridge. This is a 10-metre long bridge, 2 metres wide for pedestrian traffic. This footbridge will be a critical step in the development of 3D printed concrete structures. It will be the first Eurocode compliant structure to be made in this way. 3D printing gives us the chance to revolutionise how we use materials like concrete and steel. It gives us the chance to have savings in material quantities, in labour, in time, but most importantly in cost and carbon. And these are big potential savings. So for a material reduction of the order of 50%, we can generate carbon savings at the same level, 50%, and cost savings in the region of 20 to 30%. I love working with HTL. It's been a really good relationship over the last couple of years. They've built up good experience with their equipment, and they really love to try to push the boundaries of what's possible with 3D printing with concrete. They've helped work and print many of my prototypes up to this point. And today and over the next few days, we're going to be making the first bridge elements, which really shows us the flexibility of what's possible.
I'm very excited to be working with Andy. Be looking forward to this project and the design optimization, especially regarding the minimass beams. It's a great application for 3D construction printing, especially where 3D printing is very much focused on design optimization and only needing to place material where necessary, which ties in beautifully with Minimass's design concept.
So the differentiator and the reason why I like to work with HTL and COBOD is because we're using actual concrete. This is code compliant concrete. It comes out of the back of a ready mix wagon, so it's available wherever you can normally find concrete. The material that we use is very important. In the past, 3D printing was done with a high cement, mortar or grout mix, almost like a paste. But what we're able to do now is use ready mix concrete. And that's a fantastically important point because, first of all, it's code compliant. Secondly, it's available almost wherever you go in any country that you're working. And thirdly, it's low cost because the supply chain already exists. So it comes to us in the back of a ready-mix wagon. We're able to put it then into the printer pump. It gets pumped through the system until at the point of the printer nozzle, there is another hopper where the 3D printing additives are mixed in, and it is at that point that the material is, if you like, 3D printed ink. And at that point, the consistency of the material is ready to go. So when you see it come out of the nozzle, it's quite a firm concrete. It's not sloppy, it doesn't spill around everywhere. And because of the additive, it goes off quite quickly and allows you to print layer by layer. Critically, the mix that we're using has aggregates in it. And now aggregates give you many advantages, one of them being cost, because if you have aggregates in there, then you can take cement out, and cement is the expensive part. But it also gives us the ability to call it concrete, because anything with aggregates in over a certain size is actual concrete, and anything when you don't have aggregates in is a mortar or grout. So to comply with the Eurocodes for concrete, you've got to print with aggregates. In the past, 3D printing has been used for compression-only structures. And that's because it's very difficult to incorporate reinforcement in 3D printed concrete structures. And without reinforcement, it's hard to make reinforced concrete. What we've done is find a way to sidestep that problem. We're able to make structures where we're taking the advantages of 3D printing, giving us the freedom with geometry, but also reinforce them, and in the case of the bridge, post-tension them so that we get excellent structural performance. As our bridge is a first-of-a-kind demonstrator project, we are trying to gather as much data as we absolutely can. So we're working with our project partner Epsimon, who have given us the ability to install fibre optic strain gauges on the reinforcement in the top and the bottom. This gives us the chance to map in real time the performance of the structure for stresses and strains under the load during the lifetime. We're also measuring temperature in the concrete as we go, and that will also help us to show and demonstrate the evolution of the concrete strength and creep over time. It's possible for us to move the printer. Now, normally we will make our beams in a factory-like setting, which might be outdoors or indoors, but in a sort of fixed location. But it is also possible to move the printer to a construction site. If you have space to set it up, then it only takes a day to set up and a day to break down. So if you were working for a couple of weeks making these structures, you could certainly move it to your site, do the work there, and take it away again afterwards. That avoids all of the delivery issues you normally have with precast and prefabricated concrete structures.